Hello, everyone. Welcome back to another Fireside Chat. We are live again. So this is Fireside Chat 37. So a few minutes ago, like we were talking to each other, so like, okay, what could we talk about this time? And one topic that we deal a lot with is monoliths, because as you might know, we do a lot of software modernization work, and we come across all sorts of monoliths. And I said, like, why don't we have a chat about like the most common issues that we find when dealing with monoliths, and how do we deal with them? So we know that as we were just discussing a few ideas, it's like, look, this might be a big episode because there's so much to talk about in terms of monoliths and legacy codes and stuff. So we said, you know what, let's pick one topic at a time. We describe the issue and how we deal with it, and if we have more to talk about, we have other episodes as well. And I would like to invite you that joined us live. I can see that Muhammad is already there, as always. So always good to have you there, Muhammad. To also add your topics to the live channel, as live chat as well, to say, hey, if you are dealing with monoliths or had experience with monoliths, what are the most common problems that we find? And then we can also talk about that. Yeah. So guys, like monoliths. I believe that there are a lot of pros and cons with monoliths, but what are the main issues that we normally find with monoliths, and how do we deal with them?
Okay. I guess I'll start. Yeah. So the main thing that I see would be the mess, basically, because you have everything in one place, and that has advantages.
The
Yeah.
spaghetti.
But it has disadvantages as well, especially if you haven't been disciplined about it, right? Like you, because there are many types of monolith. No, you can have a well structured monolith, and things can be, in the place and isolated and all that, so you can get the cohesion uh within the unit, right?
Mm.
But it also, because there's nothing enforcing that cohesion, or that, or at least that encapsulation of a certain behavior, it's also very easy to skip that, and it tends to be the main the main thing that people do, right? Like especially I don't know if it's because of time constraints. Is it because the people tend to hack around a lot on that kind of stuff, and all of that stays there, and eventually over time it just becomes spaghetti code, right? A big bowl of the big bowl of mud, no. And that's the main issue that you find, right? Like, because once you're in that place, everything else becomes difficult. Not only adding new features, not, if you want to split things out, it's very hard. If everything is a mess, or the code base is a mess, then doing anything else is difficult. I don't know. What do you think?
I, I would totally agree. I think, as Mohammed is saying as well, that it gives an impression monolith itself is bad, and that's not the case. I think what we are specifically talking about is an unstructured monolith, or spaghetti code, or big ball of mud, that kind of thing that you see. And the big problem with that is that that thing is very difficult to reason about and change, right? So this is, like, at the very base level, that's the problem. You can't The code is so big that you can't really uh, take the whole in. You have to spend years and years on it to get familiarity with it, so that you can make those changes. And also, the changes are not safe. So it's not just about finding the right thing to change, but also how safe it is, right? You don't you don't have a full idea of what side effects you are causing, what could go wrong with the chain that you're making, what impact you have on the features that already exist in that monolith. And I think
Do,
that is one of the most basic problems that you get with it.
Yeah, yeah. So the thing about the code base being a mess, this is not only a characteristic of a monolith, right? So it's more apparent. We hear more that. more of that, like when we are dealing with larger systems or larger deployables, if you like, than when you have like smaller systems. But you hear that a lot. Oh, the code base is a mess. I don't know any one of you. Like, have you ever been in a project where the developer said, "Wow, the code base is pristine. The code base is amazing." So very, there will be very few exceptions, maybe, right? So, but what I would say is, I normally, when I hear, "Oh, the code base is a mess," quite often there is a lot of truth to it, right? So, but there is an element of perception as well. So that is perceived that the code base is a mess. And what I say that is because different developers have different ideas of what a good code base should look like. And because they don't share a common understanding of what a good code base should look like, it doesn't matter how the code base is structured, because they will find, if it's not how they are familiar with, or well, if it's not structured according to their preference, they will find that it's not well designed or it's a bit messy. There is also an element of knowledge of the code base, and sometimes even in the domain model as well, because some code base, like the domain is complex, and because of the complexity of the domain, combined with the accidental complexity, that is the complexity that we create in the code base, the lack of familiarity, sometimes with the technology or the patterns used or the architecture used to structure the system, also has creates a perception of structure, of mess. And then there are skills as well, because there are certain skills in navigating complex code, because complex doesn't mean messy necessarily. Of course, that we have this idea that a
This
code base should be simple, but simple according to your degree of understanding, your degree of skills, your degree of familiarity. All of that will play into what is qualified as simple or complex
This
to you.
this is this is a really interesting thing, Sandro, because actually familiarity and skill as well. Certain people, I would argue that certain people actually perpetuate the complexity in unstructured monoliths. I remember, I think you've talked about this person a few times as well, Sandro. Like when we joined UBS, and there's a guy who he was given an award for making the most amount of changes in the code base, and you'd sit with him and you'd see how he made those changes. He had over the years built this familiarity, and how he verified different parts of the code where he, kind of hot swapped classes into kind of test systems, and uh, just added that next if statement in there, but just knew how because he knew the code base intimately. He built this proprietary skill set, and it is skill. It's definitely skill, but it actually perpetuated the problems in there. And in fact, he was becoming increasingly the only person who could actually change the code base. And once I remember I sat with him and I said to him, could you give these skills to other people so that they can work as a team with you? And he said to me, why would I want to do that?
Right. Yeah.
And
You said that
So it's
straight
not
to
just yeah. Okay. So he
because
was
then he won't be the
perpetuating
person
himself in
he
the.
won't be the hero anymore. But that, like, it's interesting you talk about skill, because I think it's not necessarily a good thing being able to deal with, like, certain people build a very proprietary skill set just for that code base. uh but and it's interesting
It is
dynamic.
slightly
there's
different because, like, what I meant was, for example, when we worked for a larger investment bank, I remember that some of the legacy systems, they normally were sent to a few other teams in other countries away from the UK, for other people to maintain. So those people, they didn't necessarily build the system. They were now just maintaining those very old and legacy systems. And I remember visiting those teams and working with them, and there is a certain skill in navigating complex code base, understanding what they do, and making change to it. This is not something that, of course, there is even better skills in gradually fixing those mess, right? Because again, it's not only dealing with them and do another patch and make it even worse over time, but there is a lot of skills in understanding what a complex code base does, that not every developer does that well. They get so annoyed because of the unfamiliarity with the code base, or because it doesn't satisfy their notion of quality. They let their emotions and they become angry and upset that they don't really understand the code and are not able to deal with that.
This
They
is
have an
this is
emotional block,
th-
you know.
this is one thing that I think is quite interesting from what you were saying, Sandra, because people tend to conflate "I don't understand it" with "it's a mess."
Yeah,
Right, like
exactly,
that's
exactly,
the key aspect there as well. No, it's okay, it might be a mess, yeah, but sometimes it's complex, it's not easy to understand. There's a cognitive load to basically be able to work with the thing, and you get frustrated, and then you close yourself to understanding or dig into the problem, and then assume that the solution is either to rewrite or to do it in your way, isolated
exactly.
from the rest, and that is only contributing to increase the complexity. So how many systems have we worked on, especially with system with old frameworks and that kind of stuff, right? Like if you work with PHP, since way back, no? You have UI, you have all of these frameworks, and people, every time that a new framework would come along and you wanted to, oh, let's start with the new framework. And then you have three or four different frameworks living in the same code base. And depending on which part of the code you want to touch, then you would have to do things one way or through
You
the
know,
old system, and that already is creating a bigger issue than just sticking to the old framework or replacing it completely. No.
but Jose, I think again, this is one of those things that could be, depending on the context, you could be right in either approach or wrong in either approach,
Yeah.
right? Because the monoliths become, and I love the term ginger shaped systems, right? Monoliths become spaghetti when you add code to, you just add that next bit of code even though it doesn't belong there, but pulling it out and making it separate is a big deal, and you don't want to do that. So you just add it in there, and that actually leads you towards the spaghetti. And I really like the ginger shape thing, because the other one that you just mentioned is like where you don't want to make the change there, because that to you is unknown and you don't really understand it. So you try to isolate the new thing to the side, but it's not really the new thing. It's just another part of that other thing that should have gone with the other thing, but you don't want to do it there
you,
because it's
you
it's
don't feel
you're
you don't
scared
feel
of it.
safe. Exactly, you're scared of
Yeah,
touching it.
and
Yeah.
so you add it over here, and then you just add the next module to your ginger,
So
and
there are,
both are actually wrong thing to do depending on the context.
On the context.
yeah,
Yeah.
Yeah.
and there is like so just getting quickly back to Mohammed, is cognitive load subjective? Yes, it is subjective. It's not subjective, I think it's relative. Probably is a better way of saying that. It's relative to your skills, to your familiarity, to your perception, to your personal attitude. Depending on how familiar you are, your attitude towards the job that you are doing and stuff like that, you have a bigger or a smaller cognitive load. So that learning will may hurt you or not, in terms of like personally you be
It's a contributing factor, because there is an element of how complex the code itself is, and how difficult to read it is, and how it's not intention revealing and all that kind of stuff,
but
and
all
how,
those
yeah,
things are relative.
yeah.
They are
So
relative to the reader, to the person working, because you can
not
find those attributes at a different level than I might find,
no no
depending
they
on my
they
familiarity, skills, and so on.
they are, but there is a base, I think. What I'm trying to say is that it's not all dependent on the reader on how complex the code is, just like it's not all dependent on the code how complex it is. Almost it's a combination of the two, because the code can be very simple, and then it is simple, it's a slightly more complex to someone, but in general is quite simple. But the code can be complex, but to some it's more complex than to others. But there is a baseline of the code itself as well. There is an objectivity in the code on how is easy or difficult it is to read with. But then On top of that, you get the skills and the knowledge and the attitude of the reader
Yeah,
as well.
well,
I think that's
I
one thing.
guess there's a part here around whether you can quantify it or not.
Hmm.
And this is, I think, part of what makes it, for me, subjective or objective. No, so you can feel it. Yeah, can you measure? Can you say, okay, so this is this baseline that we're talking about, Mash, right? That's the part that I don't entirely see. No,
Hmm.
that doesn't make it entirely objective for me. Right? Like that.
Mhm.
That's the way
No, no,
that.
the baseline itself is not what I'm trying to say is that, like taking it to the extreme, a five-line method that is the only piece you have for the whole system is very simple, right? Whereas, and then of course you build on the. I'm just kind of there is. I'm not talking about the
Oh,
baseline that all codes have a baseline. I'm not. What I'm talking about is that the code itself has inherent readability and reasonability, regardless of who's going to read it. But of course, the reader also has skill, which is regardless of the kind of code that they are reading.
okay.
So I
Well,
have like the
lines of code, I don't think that's a good measurement, because I was just looking at an algorithm the other day, and it was just 5 lines of code
That's not, you
of
know what I mean.
operators of
You know
you
what
know
I
and
mean.
yeah.
and
Oh,
and shift left
No,
X
I
number of
think that
lines or with
you
this, you know what I
I
mean?
know, but
Like
that's just taking the
but see,
argument and creating
no,
a
no,
straw
yeah,
man.
we know what you mean, but I have an experience, and that's a real fact, like that talks exactly that. There was a conference in US that I went to. That goes probably back maybe 12 to 13 years or something like that, and most of the people were from Ruby. They were Ruby developers. And that was back in the day where functional programming was becoming a bit cool among the object-oriented programming languages. Yeah. So a lot of people in like in the OO were trying to get closer to functional programming. So Michael Feathers was giving a talk in Chicago, and the audience was 90% Ruby, and he showed around, I don't know, 5 to 7 lines of code just with dot these, and he was mixing maps and reduces and all this kind of stuff, which back then was not a common thing for a lot of us, right? And he was asking who could understand that, what that code was doing, and very few hands trying to give it a go, and not everyone said much, and then he said, look, this is part of the core Ruby now. And he was talking exactly about that. So like, for the people that are familiar with concepts like map reduce and functional programming and stuff, this is quite clear what it does. But someone that is not familiar, even using a familiar programming language, will find this code quite cryptic. And that's what I was talking about, familiarity and stuff. But anyway, what we explored a lot of this. How do we deal with this perception of mess? Because every developer says, oh, this code is mess, and I'm upset, I want another project, I don't want to work with this shit anymore. How can we try to reduce this problem?
Well, it really depends on what you're trying to achieve, right? Like if it is about overall solving the issue, right? Like because again, you can treat the symptom, no, or you can treat the root cause, and sometimes you just want to get your stuff done, so you treat the symptom. Sometimes you want to get rid of the problem overall, independently of delivering the thing, and then you have to treat the root cause. And you need to understand where that is coming from if you want to treat the root cause. Otherwise, you're not solving the issue completely. So I think that's important. So first, understanding where that is coming from, right? uh for instance, is it, people don't know how to do, what good design would look like, or they don't have the skill set in order to let's say properly test or divide, or whatever it is that you want to do with that. So that is one area, understanding where that is coming from. And then there's the mitigation side of things, right? Like, how do you treat the symptom the same time that you're working the root cause, right? And this is things like, refactoring, the Boy Scout rule, that kind of stuff, right? Like, leave things better than you found them. Now, if every time that you go there and you add a new feature, and you clean things up a little bit, no, eventually you're moving in the direction that you want. Yeah. Again, it all depends on what you're trying to accomplish, because if you have a deadline on top of that, or if you have then the solution space kind of
but
changes, no?
I think Jose, there is a more basic thing even before all those things, and those things
Okay.
are definitely relevant, but there is a more basic thing. It's like, as developers, and this is, I don't know, maybe I'm getting old, but this is becoming increasingly more popular, is that we are becoming more and more opinionated, and our opinions ride our emotions before we even get started. And I'm talking about that beginner's mind, right? When you come to a code base, like, reserve judgment, like, come to a project, come to anything else. It's like, first of all, try to understand the whole thing. It might be shit, it might be whatever, but first of all, reserve judgment. If it's difficult, manage your emotions and follow through and understand. And I think
Mhm.
this is a skill. It's a mindset. It's a way of being. I don't know what it is,
An
but that's
attitude.
that's a basic thing, regardless of all those refactoring techniques that you have in your things, and the things that you love to do, and the solid principles that you've learned, and the four rules of simple design, and the new frameworks, everything. Like, hold them to the side. Just try to understand what's there. And I think a lot of the time people are not taking that time
Mhm.
to do that, and that's the base, I think, the basic mindset that needs to be there in order to deal with these kind of monoliths.
I would say a very similar thing. Like I was just like the word that I had in my head was attitude. First of all, I would try to solve the attitude. So like, you know what, it doesn't like, it's not going to help you if you just start complaining about. I think we even talked about in a previous episode about the minimum viable professional. We talked about complaining and stuff like that, if I'm not wrong. So I would resolve the attitude first of all. Say, look, you know what, we are here to make this better and to keep working with this. So let's remove the bad attitude to start with, and then go dig a bit deeper into why do we perceive that code should be a mess, and then address that. For example, is it just perception? Then I would say, okay, do we have different ideas of what a good code base should look like? Because if this is the problem, it doesn't matter how we refactor, we are going to still be thinking exactly the same way. So I would just create that baseline and say, like, let's agree on some quality principles or design principles or whatever that quality principles would look like, from the low level to the high level. Let's agree on that, because we are going to start moving this code base towards this, and we need all to be aligned, right? So if that is one thing. Another thing that we have in one existing project right now, I'm not going to name to save the people there, but like, there is an existing project we have at the moment, that one of the key problems that we are having there is domain knowledge. The system is extremely complex. It's in the logistic area, and because of the lack of domain knowledge, because the intrinsic problem is complex, and of course there is accidental complexity, no doubt, in the system. The patterns that are being used to solve the problem are also not the most common available patterns. We are using sagas and things like that. So uh, the but what was beneficial already, we ran a few workshops with the client just to teach us the business, how the business actually works, and that already helped us to understand what the code base is doing. So, and then again, there are the skills that I mentioned what Michael Fetters was doing. So if, for example, we were in a project where we were all Java developers asked to code in Scala, and we wrote Scala in Java. Well, the code in Scala was written as we wrote the Java code. So there is a skill in that as well. For example, if I was thrown in a closure project right now, I would make a mess, right? So there are different solutions or different things we need to do to address this notion of
I,
uh,
I think there's an important point you mentioned there, Sandro, and I think it's worth elaborating on, is the accidental versus the inherent
yeah.
complexity. And when
Mhm.
you go into systems, the inherent complexity is the complexity in the problem. And you can't get rid of that unless you re-engineer the business and the business processes. right? And you can, but that's a different kind of battle. um, and but as developers we need to teach ourselves how to deal with inherent complexity, and that is that we need to learn the domain, as you were saying. We need to fully understand and then there is the accidental complexity, and that's where, how you design the system, what languages you use, whether they are used right, whether they're following the idiomatic kind of patterns for that language and for that way of working. So the first is the inherent complexity, and we should learn how to deal with that, and how to learn it, and give some time to that. Because often, I mean, throughout my career, I have found that, good developers who are, really prize themselves of developing well, would shy away from actually learning the domain,
Okay.
and that doesn't help. That just
Yeah, I
hinders
remember like
them.
even at UBS that we were even recommended that the life cycle of a trade.
Yeah,
Remember
yeah,
that
yeah,
that
yeah.
book? We had to learn the business in order to be able to work with those systems.
Exactly.
But
There is a
again,
question.
this
No, sorry, go on,
sorry,
Jose.
no, because before it seemed like, because what I said was very much aligned with that. Yes, you need to. Well, what I was saying is you need to understand what the root causes are. Yeah,
Mhm.
and you need to understand how to treat symptoms in order for you, while you're working on the root cause, you can also treat the symptoms. Yeah, and of course, if you need to understand the root cause, you need to understand what is happening, and that includes for me, knowing the domain, knowing what is already in there, etc., etc. So there's no mismatch between what we were saying, right? We're actually very much aligned that there is a component here that we haven't discussed, though, which what I was trying to refer to, which is the time that you have in order to do. It's not the same to have a horizon of we need to get this stuff done, in 2 weeks and chip it out. No, than if this is something that you're going to be working on for the whole year, iteratively and incrementally. You're still chipping out feature out, but you have a year to tidy up, so to speak, and do things in different stages and really evolve that. And those the time constraint and resources constraint and knowledge constraint that you have, no, a kind of set certain boundaries that you have to within which you have to work, right?
Yeah.
And that kind of reduces the number of solutions
Sure.
that you
That's
can
a very
apply.
that's a very good point, because yeah, if someone says to you that's a tactical thing, we got a couple of changes to make there, and then we're not going to touch that thing for another year or 2 years. You don't then go and say, well, actually, let me
I'm
really
gonna
learn
buy a
about the
book. Yeah,
domain. Give me a
exactly.
couple of months, I will become a domain expert, and then I will start making some changes. uh, yeah, no, totally,
No,
it's a very good
that's fair
point.
enough. There is a comment from Marabezi here, uh, but then again, I think the industry has a problem. How can we keep developers happy with such code base? So I don't think that we can solve that problem because, like, I think that we would be solving the wrong problem because, like, you the developers are like normal people. They have different preferences. So you cannot make all the developers in your team happy regardless of what you do and which projects you give. So some developers will be happy about certain projects, others will not. But I would try to think about the attitude because, like, ultimately, I know that it sucks to say that, but it's this reality. Like, we don't pay, for example, when I have an accountant working for us, or a dentist, or a plumber, or whoever we hired, as we mentioned these examples many times before. I couldn't care less about if they're happy or not. They need to do a job. If they don't like their job, they need to do a different job, right? So ultimately, there is a job to be done. But there, of course, that companies that have loads of developers, of course, that they need to look after the health of them. But trying to please every developer will not work.
you know you
So
know
yeah, go on, Mash.
Sorry, Sandro. Like this is I remember having a conversation with a few friends who are not in software development, and I was trying to explain to them that software developers have this idea of sexy code, or code that they're really happy to work with, and the code that they're not happy to work with. And it's so funny because we take it as a given. They could not understand the concept. They said, like, are you developers or not? And if you are developers, then, like, how is it that you you like easy work but you don't like
Like-
harder work? I mean, I don't like, one of them is like my they're in social work and medical and so on. We don't take a patient that has really difficult health issues and say, "Mm-mm, this is not good
exactly.
work. I don't want
Oh
to do
no,
this
I'm
work."
gonna let
But
me
this
go
patient
find
here
the
I'm not
next
going to
one.
deal with. Now,
Next
it's not
one
the
is
kind of stuff that I like doing. Yeah.
And I never saw it that way. Like, we almost take it as a given. Oh yeah, it's fine, like, yeah, oh poor you, it's such a difficult project, blah blah. But like, they don't understand that dichotomy from outside coming in. They don't understand it, and
I have
rightfully
a
so.
now that you're saying that, I can see where maybe some of that is coming from, and I think it has to do with how prepared do you feel to work with something like that, with the difficult situation versus the non-difficult situation. I think that has a lot to do. Yeah, I mean, there are many factors. You have CV driven development and all that stuff, but we can talk about that, right? But if you find yourself in a greenfield situation, yeah, you're basically, you have the support of whatever new technology you're going to use, or the tutorials or whatever, right? And whatever it is that you do, so you understand everything from scratch. You're a lot more comfortable, adding to your own mess, because you're building that cognition of the system as you're building it, right? So that's easier to do to some extent.
Mhm.
Yeah. Then if you have to absorb all of this stuff and then use, you cannot jump to where you want to go. You have to go in steps in order to make it easy for you, or to work within the constraints, if it's a live system, and those skills are not taught.
Mm.
Yeah, so you're ill prepared to deal with that. Therefore, you're not very comfortable. No, it's like, let's say if you're I don't know, the doctor example is, no, it's because you study medicine for many years, and you study, there's a baseline that you study, and then you specialize in things, right? So you have some idea of how to know. But imagine, taking a regular family doctor, or no, and asking them to go and operate on this very critical patient. That's the
I
analogy
think
there,
it's a
right?
it's a very
that,
it's a,
that
it's a very
that's
good.
the, that's the analogy that I see
Yeah,
there.
no, it's a very good point. But even then, like, if you get a GP and say, okay, here's a heart patient, could you do surgery on it? The thing that they will say is that, I don't have the skills for that.
Yes.
It's a worthwhile thing to do. It
They,
needs
they
to be
will not
done.
say that the problem is the patient.
Exactly.
Yeah, they
No,
would
I
not
have
say
all
the
the
problem is the
skills.
Oh,
The
patient.
patient that is wrong.
that patient.
Yeah, like exactly.
Exactly. I think there is the subtlety, right?
Yeah. No,
Uh,
again, and this goes back to to having a code, and the development, or software engineer, whatever, being an early stage profession kind of thing now, and software craftsmanship, and all of that stuff. But yeah, I agree that that's part of the of the
Guys,
thing. No.
so we had just before this episode, for whoever is listening, like we said, let's talk about the problem that we find in monolith. We had like a small list of bullet points. We managed to cover one in half an hour.
and I
So
don't think
uh,
we've covered that one
We
well.
can still continue talking
and we can
about it,
still continue for
because
another half an hour, right? So, but like, what else? So we talked about the code base being a mess, and all the things associated to it. But what else? When we are talking about, I'll make it a bit bigger than monolith, like when we are dealing with legacy normally, right? So,
Mhm.
uh, what else? What else do we find that is
I
common?
think a good next step would be to talk about, let's say, correctness or verification, or being,
Mhm.
going about this fear of not touching things, and
Being
contributing
able
to
to
the mess
change
because you're
safely.
afraid of touching the thing. So basically ensuring that if you're going to be working with that, and you're new to the system, you don't have all of this knowledge, or previous knowledge, how do you make it so that you have this safety net that allows you to work on it properly? Because a lot of the times these systems have grown, and the only source of truth that you have on how the system is supposed to behave, and what the business logic actually is, and so on, is the system, right? This is the, and things could be hidden, Yeah, that like I've seen a system where you have business logic in stored procedures in the database. Yeah, and
Yeah.
then some other part in this other system in PHP, and then this other thing in .NET, and like it's all spread out. So bringing all of that together, if you had a way or a source to go to that would ease that cognitive load as well, then you may know, and you may devise a way to verify that what you're doing is not breaking things up, and then you get more comfortable in making these changes and evolving. And but that is actually hard when you're starting from something that is a mess, right?
Yeah.
And again, this requires a specific set of skills for that, right? Like you have things like golden master and all this stuff where you kind of do kind of a black box if you will, no testing kind of approach where you're okay, so it's supposed, I put some stuff in, this comes out, and then you're kind of building that safety net without actually knowing what is inside the box, and then you start making certain changes. No, so I think that would be a good aspect of how do you do that. No, how do you make sure that the system is testable so that you can do it, and testable, because this is another problem. The speed at which you're able to get that feedback loop or something is very important as well. If
That's what I
and
was
this is
saying.
this
Yeah.
is common, you have this model and then you have to set up 5 to 10 dependencies and bring all this stuff so that then an automatic script or someone manually yeah goes in, types in some numbers, clicks on the thing, then goes somewhere else, verifies that, like that's a very long feedback loop, yeah, in order to know if something
So
is right or wrong, no?
again, this is one of those things where people go on into extremes. Yeah. Verifiability is extremely important. I mean, without it, you will always be guessing if you made s- something wrong, and it's actually complex. Verifying the system as a whole, not that your feature works, but that you haven't broken anything else, is easy said than done, right? But like speaking about the feedback loop, this is actually something that is I've seen in people going in very different directions. I've seen real big proponents of test driven development only relying on unit tests or the tests that run on their machine and think that they're done, and complaining about everything else, and not like, even for example, the complexity of how big the database is, that this particular chain that I will make may scan my production database that has a you know 60 million rows in there, and this field is not indexed. They don't really go down in towards those kind of things. Oh, my unit tests are passing and fine. And I have seen uh, people writing part of a system where they don't know how to deploy the whole system, and they haven't even seen the front end for that thing, right? So they're not testing the whole system. They don't even know how in some cases they don't even know what the full system looks like. And there is another problem on the other side as well. And what has happened is, often in these kind of cases, I had people coming and complaining, like, they're making changes and they're failing in production. And if only they could just run it in one of the test systems and see their feature, they would have seen it fail. And so there is this whole, the way I always talk to people on how your system should be, is that you should have verification at different levels. You should have the full system running, and you should be in your tight TDD loops, but you should always be seeing the system from the outside as well, on how you're impacting it. And those loops you should be in and out of this frequently, within minutes, of these kind of different levels of different viewpoints, right? And if you're not doing that, then you're compensating one for the other. Either you're too far one end or the other side.
So here's the thing, right? It might be a bit unpopular what I'm gonna say now.
Brace yourself.
it- so when you were saying, I was seeing people going to the other side. I thought that you would say something else. So, for example, because one side for me would be some people go there and make the changes without tests, and they rely purely on the the manual test regression that happens later on, and so on. The other side that I've seen is for the very purists about TDD and test automation. And by the way, I don't want to be misunderstood, because we are big advocates for test automation, test-driven development. So I believe that people know me can discern that I'm not against those things. But what I'm trying to say is that I've seen the other extreme. The other extreme is to say, I refuse to make any change while I don't have an automated test suite in place. And this, there is a problem, because when you are dealing with certain legacy systems, retrofitting those tests, mainly at the system level, is so complicated. Even if you try to get to a golden master, for example, I've seen teams spending weeks to have a small part of their golden master to be done, because they need to capture, they need to intercept the system as they run the thing, to intercept all those different side effects that might not only be a database, might be calls to other systems, might even be callbacks, asynchronous callbacks coming back. So there are all sorts of complexity in there. So then they go on for weeks, sometimes even months, creating a test suite without making the change that they could have made. Because before that, people spent years making change without tests, and is still pushing that to production eventually. So the other extreme is also bad. So sometimes what I feel is your system is not prepared to be tested at multiple levels, or to get them prepared to test at multiple levels might take days, weeks, or even longer. And sometimes I would be an advocate for, at least at the beginning, to do what they were doing before and making the actual changes and test manually. But as they are making the change, they start pushing the code to a better shape, so then that it will be easier to retrofit the test. Because sometimes just trying to put the system tests and then go inwards until you are able to refactor, it takes too long. Sometimes, you know what, put a cowboy hat,
This is
do the
one
bloody
example.
refactor, test manually. And once the code is already tested manually with the refactor, at that point you could retrofit, because it will be easier. So there is an element to that as well.
Yeah,
This is one example of the time constraints that I was referring to before as well. Yeah, that's another thing. But
yeah,
yeah, and there,
yeah.
yeah,
I
go
have
go.
an anecdote. Remember, it's sadly it's one of our consultants who had to make a change to a script, a bash script, and and it was a small change, and decided to write a unit test system for bash script before they would make that, and then write the tests, and then make the change to that bash script. So a job that required a couple of days to do was spent, I think, a couple of months doing it, and that is not being professional.
No.
It applies all the things that we advocate, but in the wrong way. Yeah.
Yeah. So I think this is the thing, right? So uh, you need to balance those things. Of course, like you cannot run before you walk, right? So if you're dealing with a very large legacy system that has no test, is a spaghetti, all messy, you cannot wait for it to be fully tested at multiple levels for you to start making change,
Yeah.
because they were able to make change and go live with the system without a single test before.
Yeah. And
Again, of course, it was not ideal. Of course, it took some time to do all the manual tests, no doubt, but it was still faster than waiting now for a full regression test in a larger system.
yeah.
So you need to balance those things.
And the other thing is, there is no harm in asking those people on how they, because how they were making those changes, because there is this kind of familiarity with the system where they know that certain places are difficult to touch and others are easy to touch, or not to change that variable, or not to do that little thing. They have this built-in knowledge that is allowing them to make changes safer. So that's one aspect, is that you start using those people to help you understand where the changes may be safer or not. The other thing is that there are well-known refactoring techniques, right? In working effectively with legacy
Yeah,
code by Michael Feathers has a lot of them, where you can rely on certain techniques to make changes that are safe or
exactly.
safe-ish. So you just have to be disciplined. Verifying is obviously the holy grail. Being able to verify that you made correct changes and haven't impacted other things inadvertently is the holy grail. But you can also make, like, rely on tools, compilers, your IDs, and all those things to make changes that are not gonna be a big problem, right? So you can make safer changes in that way
Exactly.
as well.
Because you can liaise with QA, for example, whoever does the manual tests, and say, look, how do you test it today? How do you test it manually? Because somehow they push stuff out, right? So hopefully with not so many bugs. Uh, and then I say, okay, how do you do that today? Okay, we're going to take this very small part of the system here that is critical for us to evolve. And we want to put all the automated tests and all the manual tests and stuff, but we need to get this feature. So why don't we? So we are going to make a few changes using some safe refactorings, or even like sometimes bringing more people, like either pairing or even bring another person to review, people that have more familiarity with that area of the system, and make the change without the tests even, right? Do some change and stuff, and then use the knowledge with QA, work together. So like, okay, if you had to test that again, but now let's test this version of the code in here. Can we guarantee that it's working well to the degree that you would guarantee the old one to work with no automated tests? Because if yes, then okay, we moved forward and faster. And now the new version of the code is ready. Okay, now we know that it works. Now that we said, like QA would say, okay, this is working, they would be comfortable to push it out. Now that is in a much better shape, let's retrofit all the tests so that from now on, it will be much easier to change and we don't need to go through this process again. But sometimes this is not an approach that is a lot that people talk much about. But I think that this is a thing that people should consider when dealing with very complex legacy code without tests. It's faster to do this way, right? So,
There are
uh,
other.
mhm.
Yeah, you no, go ahead.
No,
You
no,
were
go
gonna.
on, go on.
No, there are more things. So depending on the system, another thing that could create a bit of a problem is the whole build and release pipeline, right?
Mm,
Um, First, because because it's a monolith, you need to a lot of the time just compile everything, and it's just you even if you made a small change to a specific thing, then you need to everything needs to go through it, right? So
mhm.
that's one area, and if that takes a long time, then people start trying to hack it. No, as in, what is the how can I make this change so that I don't have to build the whole the whole system? And already starts introducing that accidental complexity just because you know the feedback loops are too long or too
The
complicated, right?
microservices approach in the monolith.
Yeah, yeah. I mean,
The modular monolith that
I'm gonna hot swap that class file over there.
so but you know,
yeah,
like for
yeah.
example, in some contexts, uh this hurts a lot the business, like in contexts where they have a very large and important system and they have multiple teams working on that system and everyone needs to synchronize everything that they need to do. And this is not an easy problem to solve, and that's not a quick problem to solve either. But I recommend normally to tackle these as fast as we can, and the solution to that is you need to try to have some sort of modularization. If you're going to take the modularization all the way to a separate service, regardless of the granularity of this service, it is a different matter. But you need to find a way to make sure that those different teams or individuals are able to work independently and release their things, or at least test their part of the system easily and independently without having to synchronize with anyone. Because while you don't get there, and sometimes you get there, you need to hack. You need to have some very drastic changes, and the faster you do, the better. Because if you delay too much, You're going to be building on top of that. You'll be cementing or even increasing that complexity even further.
Sandro, before we go there, I totally agree, by the way, around the modularization that you need to get to be able to get to that point. But even before we go there, there is an element to, these kind of code freezes. And, we've had this kind
Yeah.
of, this
Mhm.
team has the token so they can
Yeah,
do the
yeah.
changes. And now, a lot of this, I think, is even with a unstructured monolith, a lot of these processes are lazy thinking, or
Mhm.
these processes have been put in place by teams that don't actually do the development, or they're simply not interested in improving things, right? So because there is, even with, if your build pipeline uh, th- is well designed, you can even take an unstructured monolith and not have to do code freezes. And if, for example, you are working, and I know, like, the whole trunk driven development is all the rage, right? And then they say, oh yeah, but what if your trunk fails? Then you must fix it immediately and all the things. And I know that, like, features, branches and so on is like old fashioned and bad and all those kind of things. But there are things in the middle as well, where a lot of times where you're doing small branches, where you do a build and that passes, and then you do a kind of merge into master, and that passes, and you keep doing this a lot. So you are constantly trying to keep your master pristine without having too many issues, or your trunk pristine. And and building those kind of slightly more intelligent pipelines that work well, using things like feature flags and all these kind of things as well, you can have multiple teams working on a monolith before you get to that modularity, which is the, in a way, the ideal, right? But that takes a long time. But
No,
there is a
it
lot of low hanging fruit that you can do with just being clever about how your build pipelines and your environment deployments and production deployments work.
Yeah, but I don't remember if we discussed that in a previous episode or not, because we had so many of those conversations internally as well. You don't need to stop the world and say, hey, for the next X amount of time, you're going to just be modularizing the system. And we discussed many different approaches. You can, but you need to have an idea of what kind of modularization you want to have. This conversation needs to happen as soon as possible. You need to have these kind of pictures, like those are the things that should be separate from each other. It doesn't matter like how far you go with that work or how soon, but for example, because one approach would be you take every new feature that you need to develop, and as you are working on that feature, you start driving the code base towards that idea of modularization, and you do that gradually, one feature at a time. But you need to have that idea in mind. You don't need to stop the world and do,
Hmm. Hmm.
uh, given the yeah the needs of the business and priorities.
Yeah.
And
There
once you have, sorry,
Sorry, go on, Jose.
and once you have clarity around that, then you can start enforcing it, even at the tool level, right? Like there are things that you can put in your pipeline that will tell you, that will flag, for instance, is there, someone is not following the layered approach that you propose, or that if certain modules are talking to other modules that you don't want, to be connected, because you're trying to reduce the dependency, that kind of stuff. So, but if you don't have that visibility of where you want to go, it's really difficult to then enforce that at the tool level, even if you have the tools to do it, right? Because then, basically, what are you going to work towards, right?
Mhm.
Mm.
So there is a comment from Marabezi on the chat. Any opinions on how monolith became a negative thing for software, like monolith equals bad? Are there places which monolith is a good fit? So my opinion on this is not on the monolith itself, is the problems that are caused uh, by certain types of monoliths. For example, it becomes very difficult to parallelize work because of the things that we were discussing here. If the monolith is is a spaghetti, all the changes need to be synchronized because we are always releasing the entire monolith, which means that everyone that worked on that monolith, all the work done by different people, different teams in that monolith, needs to be synchronized, test together, release together. And this is an issue. Like if you just have one team, a small team working the monolith, normally that's not a problem at all. If you have like, if you scale the problem, have multiple teams in tens, maybe even hundreds, as we had in quite a few projects of people working on the same code base, that synchronization of work becomes very difficult to deal with, and testing all those things together. And that's one of the reasons that monolith became the architecture style fell in is not favorable anymore. So people want to parallelize work and be able to release more frequently. And for that, we need to be able to parallelize the work easily and test each thing individually more easily and faster, which is much harder in a monolith. That is,
Yeah.
yeah,
Even in one team, I think again that's why we talk about unstructured monolith or spaghetti code. And monolith inherently isn't a bad thing. I think it's like, following those principles of low coupling and high cohesion. As long as you have that, and it's all in a single deployment, and you're in one team, and you don't have to you know work with a lot of other teams to
yeah,
make changes happen, then it's the right way to go. It's not a wrong approach without any context. It is, in fact, if you do have lots of services and so on, you will have to have a complex deployment system. You'll have to have complex environments and all those kind of things, and how you test those things locally as well. That also makes, so you move complexity to a different place. So it's like you give some to get something. And if you have multiple modules deployed separately in services, then you give the complexity of deployment to get the parallelization and the
mhm.
lower cognitive load of making a kind of change.
And
Yeah.
also
You
you,
think about a plugin architecture
Mm.
yeah,
or
yeah,
something like that.
exactly. And but you need to be again very thoughtful about how you go about doing that, because then if you create the wrong boundaries, then you're in for a disaster basically. So you're just multiplying your problem and increasing the complexity, because now on top of all the dependencies and the synchronization you needed to do, you increase the all of the deployment aspects as well,
and
right? And
and
observability and traceability, like all of the things that come with that trade-off that you're supposed to
and
be doing,
you
so
know
you need
what
to do it properly.
what usually happens is, and a long time ago, I remember I wrote a blog post called Premature Microservices. And what normally happens is that when you draw these boundaries prematurely, you've created quite a hard thing to replace, right? So when people say, oh, you know what, this particular feature, it doesn't fit in, it fits in between those boundaries. So what do? They don't obviously take those things and redraw the boundaries. What they do is they put that things in an existing place, and it's the wrong place. So what starts happening is that you get these, your nice kind of cohesive microservices are no longer cohesive. So what you get is basically a network of unstructured monoliths where
Yeah, I think that
functionality
Simon Brown calls it a distributed
The
monolith.
are
distributed
distributed. Yeah,
monolith, the distributed monolith.
I
Yeah.
think
Yeah,
that, yeah, that's, yes, yes, totally. I mean, because what you then have to, and there are other patterns that lead you to distributed monolith as well, but this does as well, right? Because then you
yeah,
have basically knowledge distributed in multiple places that you then have to make changes and in sync, which is actually way more difficult, right?
exactly. This is
And
Synchronizing
you
exactly
change
why
changes
it.
that they
across
say, because the science is exactly that. Because you change one service and you need to change more services, and we need to always deploy that set of services together.
in
And that's
sync.
the
And that's such a
characteristic of a
difficult problem
distributed.
to solve. Yeah, it's such a difficult problem to solve, and that problem doesn't happen with the monolith. So it's all, and Marbasi is asking for like maintenance of monolith is quite painful as well. I guess it's deploy. Oh, sorry, that's Laura asking, and you asked painful how. um, and it can be painful because so many changes have to go in at once, and it's like all or nothing. You've got to deploy the whole thing, or you haven't been able to deploy the whole thing. You haven't been able to isolate your deployments either, and that can be painful. But on the other hand, microservices, their deployment is inherently painful, And that's why, like when you come to a microservices based approach, they talk about platform automation from the very start,
From the
because
beginning.
if you don't have that, you're in a world of pain.
Exactly. So the monitoring of all those services and what Jose
No,
mentioned.
and
But
also once you let's say you have all of that in place, even debugging, if you get a defect in production, even debugging across those
across
boundaries
boundaries and
and
services, yeah.
understanding what is happening, like what is happening, becomes a lot
Mm.
more difficult as well, right?
Mhm.
So yeah, no,
Yeah.
no, great. um,
Yeah, but also but like the point that Laura was mentioning, of course, that if you make a change and your base is much smaller because it's a smaller service instead of being the full app, you reduce the chances of breaking other things. So your changes tend to be localized, and if even if there is a problem, the problem is also localized. That area of the system might not be working very well, but hopefully, depending on how it was designed, everything else should still work as expected. So we've been going for an hour. So this is a huge topic. I had a lot of fun discussing this. I believe that we can go for another hour easily, and there are so many things to talk about, legacy and monoliths.
And
So what we
distributed
yeah,
monoliths.
and distributed monolith.
I think there's a lot
Emmanuel
to
just
talk
joined
about
here.
that there. Yeah.
Yeah,
Yeah.
we just mentioned that now, but we are running out of time. So any final thoughts, like any to wrap up, and then we might have another episode on this so that we can continue the conversation.
So I can start with the final thoughts. I think, we started with this thing about the attitude. I think it's a very important thing that we need to change this. We need to adopt this attitude that all software is, keep the judgment at bay and try to walk in those shoes. Try to be pragmatic. If someone has been delivering it in a particular way, try to walk in their shoes first before you start making judgments and start kind of already trying to refactor things. I think that's one thing. And also with monoliths, as we said, there's a lot of things that you can do to start dealing with that gradually. We always talk about, like in our service software modernization, we always talk about strategic systems, right? Because these systems are there, they are often these legacy big systems are there as the backbone of a business. And if they're a backbone of a business, it really helps to take care of it. And the way you take care of it is not by almost demonizing that thing. It's a unstructured monolith, is a legacy code, and it's used doing all this and so on, and it's bad. It's not bad, it's running the business. And as professionals, we are there to understand it and to see how we can gradually improve it while maintaining the business. And there's a lot of skill involved in it. And once you learn those skills, there's a lot of satisfaction involved in that job. That is brain surgery, right?
Yeah,
That's going to open a heart surgery, and there's a lot of skill and a lot of satisfaction to be had there, I think.
yeah. Cool. Jose, any final thoughts from you?
I guess my point is that you need to be able to learn the tools that allow you to operate on that patient independently of no, so that you feel comfortable as well, no, working in that kind of environment, and that will make it uh, a lot more rewarding, no, and it would allow you to make better choices, no, when it comes to dealing with that kind of context. So things like learning refactoring and testing, not only TDD but overall, like how to approach a system like that, and evolve it, is something that you need to build, because again, it doesn't matter if you started your system on your own. Eventually that system will also become legacy, and you will also have to deal with that, or not, if you if you leave, no. But overall, if you have those tools, then you can feel less pain, no, when dealing with a monolith, like Laura was saying before, no, like at least you'll be more prepared to deal with it, no, and to do the job. Someone was asking for recommendations. Of course, the working effectively with legacy code, the I think it's Michael Feather's book. You also have refactoring to patterns book. So those are, and refactoring databases. I think there's another one called refactoring databases as well, which is another often forgotten part of that of that work. So those, definitely check them out. And one that I would like to read, I think they're doing it right now in the book club that we have internally, but I think it's the latest Paul Vernon book, and it goes it's
Implementing
something.
domain-driven design.
No. He has a new one, something around monoliths as well.
Okay.
Well structured well designed monoliths or something like that. I don't remember the name of the book. Maybe Maravesi can put it there in the chat. But I think that could also be an interesting read. I'll check it out. It's quite recent. Strategic Monolith and Microservices. Exactly. That's the name of the book. So maybe that would be an interesting read as well. I don't know. Can't recommend it, but seems like it might tackle some of these things that we're discussing here.
Yeah, cool. Yeah, for me, it's also a matter of attitude as well. So I'm very biased. I love large systems, large and complex systems. It's what I like to work with. I don't have a lot of patience to working just building a small new feature in a small system and just like, oh yeah, it's just this serverless, write something in JavaScript and you have a new screen. Is not my bag. I like very meaty, huge systems. Uh, I find it far more challenging and exciting to work with. So there is an attitude in there. Also, a skill, aptitude towards that as well. And yeah, and some of the books, everything like on the domain-driven design, there are quite a few books from Von Vernon, from Eric Evans, from other people in that realm. Uncle Bob has a few good books that I think should be read in terms of clean code and clean architecture and things like that. I think that it should be part of that reading material. So I think that most of it, like the others mentioned already. So yeah, cool. So thank you very much for everyone. So if you are just watching these not live, but if you want to leave the comments, for example, what are the challenges that you have with legacy code or monoliths and stuff? There is a big chance that you're going to have another episode on that. So leave the comments, and we might choose them as topics for the next episode as well. So that's all from today, and I see you next week again on Tuesdays. So thank you very much.
Hit the notification
Oh
button
yes,
and all of that
it's our
stuff so
YouTube
that you
channel.
get notified when we're going to go live.
Exactly. Subscribe, hit the notification button, put thumbs up. Thank you very much, everyone. See
Thank
you on
you.
Take
Tuesday.
care.